morning, students. Now, welcome back to science class on the chapter of force. In the previous class, we discussed about force, right? What are the balanced and unbalanced forces. So, to keep to bring objects from rest to motion or motion to rest, or if you want to change the speed or velocity of an object, or if you want to change the direction of an object, so force is necessary. So here we should apply an unbalanced force, and also we had discussed to keep one object in a continuous motion, so we have to apply an continuous unbalanced force. Okay, so this much we had discussed in the previous class also, and we discussed about the frictional force. So for example, if you kick a ball after going some distance, finally it will come to rest. Why? Because that is due to the frictional force. That friction force always which acts in the opposite to the direction of the motion of an object. Suppose say if the ball is moving in this direction, then the friction force it acts in this direction. Suppose the ball is moving in this direction, then friction force it acts in this direction. Okay, already we know using lubricants, ball bearings, and some other etc. Okay, so in this class and also in the previous class, I had discussed this one experiment. Okay, I have taken two inclined planes. Okay, so first we'll draw from here, then we'll later I reduced this inclined plane, finally made it to 0. Okay, so Galileo said that when, for example, if there is no frictional force, if there is no, just imagine, is it possible? Just imagine there is no frictional force. When you drop a ball at this point, so that ball it will climb this side and this inclined plane, and it will cover same distance. Suppose if the distance from here to 50 centimeter, then it will cover 50 centimeter only. Okay. Suppose if you drop from here, so it will cover 25 centimeter distance. So here also it will cover the same height, that is 25 centimeter. Suppose if you reduce the slope, what will happen at that time also? See, at that time also, here you are dropping that ball from a certain height, right? So here also it will climb the same height, or it will cover the same height, means that same distance, if there is no frictional force. Okay, when you make to completely zero, that slope is, it will become completely zero. Then when you drop ball from here, what will happen? It will cover the same distance. It will cover the same distance. Okay, so this experiment was done by Galileo. Finally, he said, if one object, if it is in motion, it remains in motion only when there is no force acts on that. Okay, if there are no forces, if one object, if it is in motion, then it remains in motion only. Or if one object is at rest, then it remains at rest only. Okay, this was said by Galileo. So this is a Galileo's experiment. Okay, inclined plane. So after one more famous scientist, that is Sir Isaac Newton, he studied all the experiments and observations of Galileo, and finally he gave 3 laws. Okay, first one we'll discuss. Okay, before that we'll discuss what is inertia. Okay, see, inertia means if one object, if it is in motion, it remains in motion only when in the absence of external force. Or if it is at rest, it remains at rest only. For example, so now I will keep this marker here. Okay, just here on table. I will keep this marker over that table. Okay, if you come tomorrow or day after tomorrow, after 1 week, after 1 month, after 1 year, okay, but after 10 years, this chalk it will remain here only, right? When if there is no external force. Okay, if there are no external force, if one object, if it is at rest, it remains at rest only. Already you know. Clear? So that is the property of all the objects. That is the natural property. Correct? If one object is at rest, it remains at rest only. Clear? See, now take this water bottle. Now I will keep here. Okay, if you come tomorrow, day after tomorrow, after 1 week, it will what remains there only. Do you think that it will move itself? No, right? When you are, see, for example, you will keep here. Tomorrow you will friend came, you will keep that bottle. Then only it will cover some distance, or then only it will change its position. Otherwise, it won't. It will remain there only. Okay, so that is the natural property of all the objects. What if the objects are at rest? They will remain at rest only. Okay. Next, so this is one property. One more property. What is that? If the objects are in motion, then they will remain at motion only. Suppose here I will throw this this marker. Maybe say it will cover some 50 meter, then it will come to rest, right? But what is the property I have told? If one object is, one object is in motion, then it remains in motion only. No, right? If you throw here, so it will see now it is at rest. If I throw this one, it will move to from rest to motion. But so after covering some distance, finally it will come to rest, right? Then this statement is wrong, right? When see if one object is in motion, then it remains in motion only when in the absence of external force. Here if you throw that marker, it will come to rest. Why it will come to rest? Because of gravitational force. It will attract towards earth, right? Okay, then what will happen? Then it will touches the ground. At that time the friction force, friction force always opposes the motion of an object, correct? When it touches the ground, then friction force arises. So that's the reason all the objects they will come to rest. Clear? Okay, just imagine if there is no frictional force, there is no air resistance, then there is no gravitational force. If you throw one marker, just forget that you are throwing, just forget that. Okay, if you throw one marker continuously, it will move forever it will move continuously. Are you getting my point? So this is the second natural property of all the objects in earth. That is that second statement. It is difficult, say force. But if you go space, if you throw an object, it will move continuously when in the absence of external force. Okay, so this is called inertia. So clear, right? What is inertia? Inertia means if one object, if it is at rest, it remains at rest only, or if it is in motion, it remains in motion only in the absence of the external forces. So this is the natural properties of all the objects. We can define what is inertia. Okay, already you have studied in standard, right? The tendency of an object, the tendency means what? Like a natural property. Okay, the tendency of an object to remain at rest or to remain in uniform motion in the absence of the external forces is known as inertia. So clear, right? So inertia meaning is simple. If one object is at rest, it remains at rest only. Okay, if one object is in motion, it remains in motion only. For example, see here, without one object, there is secondary. Just you and your friend are in a space. There is right now nothing. Okay, it is an empty space. Your friend is standing little bit, say 10 kilometers from a distance. You will throw that, but your friend, he doesn't know you are throwing that. Just he is simply walking in front of his eyes. That marker is moving. Okay, so that marker is moving. Okay, then it will keep on. It will move forever when by applying any other external forces or when it collides with some other asteroids, meteors, whatever it is. Okay, it remains in motion only. Okay, now how to define that inertia systematically? That is the tendency of an object to remain at rest or to remain in uniform motion in the absence of external force is known as inertia. So clear? So on this basis of inertia, so Newton gave three laws systematically. So first law of motion is also known as law of inertia, meaning same, the law of inertia and okay. The law of motion states that every body continues to be remains in its state of motion, or state of rest in the absence of external forces. So clear, right? Every body continues to remain in its state of rest or state of uniform motion in a straight line, in the absence of external force. So this is known as first law of motion. So clear, right? So we call first law of motion is also known as law of inertia. Okay. So what is the statement of first law of motion? The first law of motion, it states that every body continues to remain in its state of motion or state of rest in the absence of external forces. Okay. So now we will discuss some illustrations of inertia. Okay, we can explain some more day by day some action. Traveling on a bus or say bus or a train, you will lean forward and sometimes you will lean backwards. So we can explain those effects on the basis of inertia. Okay, just imagine, initially the bus is at rest. Okay, see what is the natural properties of all the objects at rest? It is the rest only. If it is in motion, it remains in motion only. Okay. See, for example, initially bus is at rest. You are inside the bus. You are sitting inside the bus. Both bus is at rest and you are also at rest. You are sitting in the bus seat. Driver starts the bus. Okay, he will press that accelerator. Then bus it will start move. At that time, suddenly your upper body, it moves backward, right? Lower body, which is that your lower body which is contact with the bus, so your lower body moves forward and your upper body moves backward. Why? See here, the bus is all initially the bus is also at rest and your body is also at the rest, but the driver is applying force for bus, not for your body. Are you getting my point? Not for your body. So here your body it is at rest. So that's why your body it tends to remain. It tends to remain in what is your state? See, state means not your Karnataka. And that means, for example, if one object is at rest, we'll say that that object is at rest state. Or if one object is in motion, then we can say that that object is in motion state. Okay. So clear it state means, so initially your body it is at a rest state. So here what is the natural property of your body? Your body is at rest, so your body it tends to remain at rest only. Are you getting my point? Or if your body it resists to change that state. Okay, your body it resists to change that state from rest to motion. Okay, in Kannada we can say that, see, you rest allirutiralla ನಿಮ್ಮ ಬಾಡಿ ನು ರೆಸ್ಟ್ ಅಲ್ಲೇ ಟ್ರೈ ಮಾಡ್ತಾ ರೆಸ್ಟ್ ಅಲ್ಲೇ ಇರೋದು ಅಂದ್ರೆ ರೆಸ್ಟ್ ಇಂದ ಮೋಷನ್ ಬರೋಕೆ ಅದನ್ನ ಅದು ಒಂಥರ ಇಷ್ಟಪಡಲ್ಲ. Try it is not interested like that. For your understanding purpose I am saying, okay, here your body which is not interested, clear, don't try it like that. Okay, see here, so here you are at rest, so your body which tends to remain at rest only, or which resists to change the state of rest. Okay, here the driver applies the brakes for bus, not for your body, correct? So that's why your body tends to remain at rest only. So but your lower body contact with the bus, right? So that's why your lower body which moves along with the bus moves backward. So clear? If I will ask, this is the first case. So clear, right? Why our upper body moves backward and forward? Backward. Why? Because here our body which tends to remain at rest only, or which resists to change that state of rest. Okay, which resists to change from rest to motion. But here driver applies the brakes for bus, not for your body. So that's why. But lower body is not contacted. So upper body initially it is at rest, so it tends to remain at rest only. So that's why your upper body which is moved backward. So clear, right? Next one. The bus is moving. Say when a driver he applies the brakes suddenly. At that time, what will happen? So your upper body lean forward. Means you will move forward. Why? Bus is moving, which means you are inside the bus. You are also moving, right? You are also moving. See, bus is moving with 60 km per hour. The bus speed of that bus is 60 km per hour. Then what is your speed? You are inside the bus, right? Then your speed is also 60 km per hour. Correct? See here. Now driver applies the brakes. Driver applies the brakes means what? He is applying the force, right? He is applying force for bus, not for your body. Clear? So you will apply force for that bus. What will happen? That bus its speed reduces. But what about your body? Your body it is in motion, right? So then your body tends to remain in motion only. Your body tends to remain in motion only, or your body which is resists to change that state of motion to state of rest. Clear? Are you getting my point? See, while moving, driver applies the brakes. Okay, at that time, that speed of that bus reduces, but the driver is not applying force for your body. Correct? So here also same, your lower body which is contact with bus. So that's why which is moves along with the bus, but your upper body is not contact with bus. Okay, so your upper body which tends to remain in motion only, or which resists to change state of motion to state of rest. So that's why your upper body which is moves forward. So clear, right? What the reason why we lean backward and why we lean forward? So this is due to inertia. Maybe in your exam they will ask why your upper body and lower body lean forward and backward in a bus. They'll ask whatever, but you should know the reason. They may ask, see, instead of bus they will use train. Why you lean forward and why? See, concept is same, right? What is the reason? See, the reason is one object, if it is at rest, it tends to remain at rest only. If one object is in motion, then it tends to remain in motion only. The reason is same for if you take horse cart, if you take bull cart, whatever. Okay, and the reason is same for all the questions. While asking, they will use some other words, like instead of a bus, they will use a train, they will use car, they will use a bike, like that. But the reason is same. Okay, this is very important question. In your exam, they will ask why you lean forward and why you lean backward. Here, see, first, why lean backward. Here you should write what? Here, our body, which is, see, why lean back? When you lean backward, when your body is at rest, when the bus starts suddenly or when the bus moves suddenly, then only your upper body moves backward, right? Here you should write, here our upper body which is not contact with bus or train, whatever, so our upper body which is at rest, so it tends to remain at rest only, or which resists to change the state of rest to state of motion. Okay, our lower body which is contact with bus, so that's why our lower body moves along with the train. You have to write this answer for why we lean backward. Next question, why we lean forward. So at that time, here you should write what here that bus or train, whatever we are in motion. So here our body which tends to remain in motion only. Now our body which is in motion, so our body which is tends to remain in motion or which is resist to change the state of motion to state of rest. Okay, so this is the answer for why we will lean forward. So clear, right? Then other examples, say which one? In a carom board. Okay, see, you will arrange all the coins in proper order, right? See, you will arrange. Okay, just when this is a carom board you are playing, just imagine. Okay, it looks like a carom board, but it is not carom board. Okay, see here, using the striker. Okay, using the striker, you will hit this pawn, the bottom pawn. What will happen? So this pawn will displace us. Then what about these coins? They will fall downwards, right? Correct. Why? Because here, before applying the force on this pawn, all the force are at rest. You are applying force only for the bottom pawn, not for the other pawns, right? So that's why now you are applying force for this pawn, so it will discuss its position. What about these pawns? Okay, these pawns are at rest, so these pawns they tend to remain at rest only. Clear? This is one example. And one more, I think you have played, right? So this is a paper. You will keep this paper over table, and at the bottom you will place one 5 rupees coin like this. Okay, then you will pull that paper suddenly. Okay, it stays there, right? Here also same. Why? Because you are applying a force for paper, not for coin. So here that coin is at rest. So that's why that coin which tends to remain at rest only. Okay, see here in this example, you will hit the force, right? The coin displaces. These coins will fall downwards, right? Why? These are at rest. They should remain at rest only, right? Why? Because gravitational force. That force which pulls, right? So that's why they will fall. So clear? Okay. So these are illustrations for inertia. Okay. Yes. So you got it now. What is inertia and illustrations of inertia? Okay. So now can you give some other illustrations or other examples for uh, other examples for inertia? Okay. If you know, just put it in your comment box. Quick. I will wait for your answer. Okay, so we have discussed one why we lean forward and why we lean backward. Then second one we have discussed the carrom board example. Then third one flicking a paper or flicking a card. So now give other examples. First, I'll give 2 minutes time. So put your answer in the comment box. Quick. Yes, quick. I'm waiting for your answer. Give an example. First, I am waiting for your answer. Okay, so give one explain one effect on the basis of inertia. Yes, quick. I'm waiting for your answer. So here Sonia Gowda and MD Patil, you have deleted some messages. Don't know. Yes, no one is responding. I am waiting for your answer. So give explain one phenomenon now. On the basis of inertia, give example for inertia. So already I have given 3 illustrations, right? One is carrom board, why we lean forward and backward, and another one is picking a paper or picking a card. Okay, give one more example. Yes, brakes applied when moving on a cycle. Yeah, this is similar to bus, right? Given different examples. Yeah, brake applied, that is already we have discussed. Quick, now. Train, bus, car, everything is the same. Here only that vehicle name different. Instead of car, instead of bus, that's it, okay? First, okay? Yes, see here. Next move to inertia and mass. Next move to inertia and mass. See, now take one example. See, you have one, say, one football. So, if you kick that football, it will move, it will cover some distance, okay? So now, instead of this football, take one stone, the which is the size of that stone is which is equal to the football, okay? So now kick that football. You know what will happen when you kick a stone? Definitely, your leg you hurts more. Why? Because it is a stone. Why? Because it is a stone. Okay, the stone which has more mass than ball. You know, weight and mass both are different. Weight and mass both are different. Okay, we study in the gravitation chapter. Usually we won't use that normally in your common language. We won't use that which one mass word. We will not use weight only, but it is wrong actually. Okay, it's not wrong, but mass means mass is different, weight is different. We'll discuss in the gravitation chapter or next chapter. So now we'll discuss mass and now discuss mass and inertia. Say this football has say half kg, and say this is 5 kg. Okay. See now you will apply force on this ball and this ball. Clear? So clearly we can say that this ball it covers more area, more distance, and this stone which will cover lesser distance. Definitely while kicking, definitely will get hurt. Why? Because it is a stone. Okay. See why one is mass is more and in this one it has mass less. Okay, now here clearly we can say that. So its mass is more, right? So it has more inertia. It has more inertia which resists more to change its position. This stone which resists more to change its state. Now both are at rest state, right? So if you kick here easily, it will change its state. But this one, no. Why? Because it resists more compared to the football. So that's why we can say that if the mass of the object is more, then it has more very easily. But you can't push it very easily in bus because to push that bus you need minimum 10 to 15 members. But cycle only one person is enough. Why? Because the mass of the cycle is very less compared to the bus. So that's why the mass of the bus is more. So that's why that bus has more inertia than whatever cycle that cycle has less. Okay, so inertia and lighter objects have less inertia. Okay. Objects they will resist more to change the states. Okay, one means state of rest or state of motion. Okay, they will resist more to change their state from state of rest to state of motion. The lighter objects, okay, they will change their they resist very less very easily. They'll change their state of rest or state of motion. Okay, so till now we have discussed what is inertia and first law of motion. Okay, inertia. What is inertia? The tendency of an object to remain at rest or to remain in motion in the absence of external force. Next, what is the first law of motion? The first law of motion means every body continues to remain in its state of motion or state of rest in a straight line in the absence of external force. So this is the first law of motion. Okay. And also we have discussed the illustrations of inertia. Illustrations for inertia. Why we lean forward and why we lean backward. Okay. Then the heavier objects have more inertia. What is mass? Mass is nothing. The mass of an object is a measure of its inertia. Okay. So now next to move to the second law of motion. Okay. See, first law of motion is on the basis of inertia. Now, the second law of motion is on the basis of momentum. In the previous year, in 8th standard, you have studied the second law of motion. What? The acceleration of a body, the acceleration of a body is directly proportional to the applied force and inversely proportional to the mass of an object. Okay? Right? So, acceleration is directly proportional to force of the applied force and acceleration is inversely proportional to mass of an object by combining one into we got F by M. Okay, so to remove this constant proportionality, we have introduced one constant, that is K into F divided by M. So later we have considered one unit force, means the very smallest force. That unit force, F equal to 1, M equal to 1, and acceleration equal to 1. So later we got K equal to 1. Then we have substituted that K equal to 1 in this equation. So finally we got A is equals to F by M. So then later we proved F equal to M into A. So we proved this F equal to MA on the basis of acceleration. Okay. So what it states, the signal of motion, which states the acceleration given to a body is directly proportional to the applied force and inversely proportional to the mass of an object. Okay. But this year you are going to derive once again the same expression, but on the basis of momentum. Okay. First we'll discuss what is momentum. Okay, what is momentum? I think hope you already know, you have a little bit idea about momentum. Okay, so what is momentum? Yes, can anyone define? Please put your answer in the comment box. What is momentum? Quick. What is momentum? Yes, put your answer in the comment box. What is momentum? Yes, what is momentum? I am waiting for your answer. What is momentum? What is momentum? Yes, Ishapar answered product of mass and velocity. Okay, so what is the meaning? Yes, see, I will say momentum is nothing but it's a product of mass and velocity. Then what is the meaning and actual meaning? Yes, see here. So momentum, we can say that it is a product of mass and velocity. So for example, when one object is moving, if you multiply its see, one object is moving. If you multiply mass of that object and the mass of the velocity of that object, then you will get the momentum of that object. What is the moment? Then what is the meaning? See, just imagine one cycle is moving. Okay, one cycle is coming here. Just imagine this is a cycle. Okay, if you stand in front of this cycle, what will happen? Here the dash occur means it will collide with the cycle, collide with your body. Then what dash happen? So you may get little bit hurt. Okay, but instead of this cycle, if you stand in front of a bus or a truck, okay, see, both are coming with the same speed. What will happen? You may die, right? Why? Both are coming with the same speed. Both are coming with same speed. If you stand for a cycle, you won't die. But if you stand in front of that bus, definitely you will die. Why? Why? Because that truck has huge amount of mass. Huge amount of mass compared to cycle. See, actually momentum means the quantity of motion. What is that? The quantity of motion. And here, yes, the momentum has both direction. See, that is we can discuss later. Okay, listen. See, the momentum means what? It is a quantity of motion. While moving, how much quantity it carries. For example, one object, it has more mass and it is moving. Okay, it has, see, take two objects. One is, say, mass of one object is a 10 kg. Mass of one object is 10 kg and mass of another object is 100 kg. Both are moving with same speed. If you stand in front of path of the 10 kg mass and 100, just when you are standing in front of the 10 kg mass, okay, it will collide with you. Okay, what will happen? You make a little turn. But if you stand in front of the 100 kg mass, what will happen? So in this case, you will get more hurt. Why? Because it has more mass. Means the effect from this 100 kg mass is more compared to 10 kg. Okay, that effect, that quantity of motion. Okay, to understand that collision. Okay, so we introduce one more term, that is momentum. Clear, right? The effect from 10 kg object and the effect from 100 kg, both are different. And see, I have told what? Both are moving with same speed. Both are moving with same speed. But the effect from 10 kg and 100 kg, both are different. Why? Because these mass are different. Masses are different. So clearly we can say that the effect from 100 kg of that is more compared to 10 kg. So clear, right? What is momentum? Means it is a quantity of motion. Okay, so we can define that momentum, that is, it is a product of mass and velocity. Mass and velocity. We use small p to represent momentum. Okay, here that is small p which represents momentum. So momentum we can calculate using the formula mass into velocity, that is p is equals to m into v. If one object is moving with it has mass m, say m, and it is moving with velocity v, then we can calculate its momentum by multiplying its mass and velocity. So clear, right? For example, see, here we have discussed the cycle and the truck case. So definitely, if you stand in front of the truck, definitely it will kill you. Why? Because it has huge amount of mass. Instead of this truck, take a bullet. Its mass is in a gram, right? Say 10 gram or 20 gram. Okay, what will happen? It will also kill, right? Why? See, here more mass, we can say it has more inertia, so definitely it will die. But if I, instead of this truck, if I use that one gun, what will happen? Definitely it will die, right? Why? Because the mass of the bullet is very less compared to the truck, but that bullet, it will move with huge amount of velocity. See, I will take one bullet. If I throw using my hand, it won't kill you. But I will fire. I will use that bullet through this this gun. Correct? While ejecting from this gun, it will come with a huge amount of velocity, right? Huge amount of force. Then it will kill you. If I throw that bullet, it won't kill you. Okay? See here. If you increase the mass of an object, then momentum increases. Or if you increase the velocity of an object, then momentum increases. So clear, right? So momentum means it is a quantity of motion, or we can say that it is a product of mass and velocity. In simple word, while one object is moving, how much amount of quantity is carrying. Clear? So this is about momentum. Then what is the SI unit of momentum? See here, we measure mass in kg and we measure velocity in meter per second. Okay, the SI unit of momentum is kg meter per second. Kg meter per second is the SI unit of momentum. Now tell me whether the momentum is example for a scalar quantity or vector quantity. Yes, now tell me whether momentum is example for scalar quantity or vector quantity. Fast. Momentum is an example for scalar quantity or vector quantity. Quick. Yes, it is example for vector quantity. Okay, why? Because mass is scalar and velocities, it has both direction and magnitude. Mass has only magnitude, but velocity it has both direction and magnitude. So mass is a scalar quantity and velocity is a vector quantity. So together we can say that. So momentum is a vector quantity. Why? Because see here, say one object, say its mass is 5 kg and it is moving with 2 meter per second. 2 meter per second. Now you will apply force. What will happen? See that object is moving. So this is position A. Just take that object is moving. You will apply force. What will happen? See now you are applying force in this direction. In this direction. Then its momentum changes in which direction? In this direction only, right? Its momentum changes. Okay. So that's why momentum it has both direction and magnitude. So that's why momentum is an example for vector quantity. Okay. Now tell me, uh, one object is at rest. What is the momentum of that object? Approximately. One object it has mass at 10 kg. It has mass 10 kg. It is at rest. So what is the momentum? First, what is the momentum? Quick. One object it has mass 10 kg and it is at rest position or it is at state of rest. So then what is its momentum? Wait, one object, we have one object, its mass is 10 kg. Okay, what is its momentum? Yes, its momentum is Gangayanna. We have said 10. How it is? See, before the answer, think what is momentum? Momentum means it is a product of mass and velocity. Okay. No, Sangeeta is wrong. 10 kg. How it is 10 kg meter per second? See here, one object is it is at rest, right? When the object is at rest, then what is its velocity? What is the velocity when the object is at rest? Then its velocity is equal to 0, right? Huh? So then ultimately we can say that the momentum is also equal to 0. Why? Because see, we know the formula that is P equal to m into v. Mass is 10 kg and 0. What is the value? 10 into 0. That is 0. You know, one object, that truck is now. Just imagine that a truck is at rest position. If you stand in front of that truck, do you think that it will kill you? No, right? Okay, why? Its momentum is 0. Clear? Because then there is no effect from that truck. Okay. I will stop here. So tomorrow I will continue the class. Thank you.